Hey everybody, Dr. A here, and in this video we're going to be exploring an example of tributary loading. So let's go ahead and get started. In the given information, we're being asked to determine the loading on the two support beams A and B. So in the figure here, what we have is this three-dimensional rectangular slab, and it's supporting a uniform surface load of Q equals 100 PSF. So even though it's not shown clearly on here, what we can assume is that, we've got this uniform load that's spread out over this area, over this entire slab surface of 100 pounds per square foot, okay? Now, the longer dimension of this slab is supported by these two beams that we see here in red. There's beam A and beam B. Now, beam B, it's kind of dashed underneath here to show hidden lines, which means that from this viewpoint, it's underneath a part of this slab, the edge of the slab. So that's why, if you're wondering why this looks a little choppy, that's why, okay? And we see that the length of these beams, A and B, are both 20 feet long. And then the length in between the beams, which is the length that the slab is spanning, is 15 feet. And notice that there are no supports under the other two edges of the slab, all right? So as we get started with writing our solution, the first thing we want to note is that this is a one-way system. Now, the reason why we know it's a one-way system is because only two edges are supported, okay? Only two slab edges are supported, which means that these beams, these support beams, are only running in one direction. And that also means that this 100 PSF load is only going to be transferred to those beams, right? I mean, think about it. This 100 PSF load, it's got to go somewhere, okay? And so it's going to be transmitted in one direction. Half of it is going to go to beam A, and the other half has to go to beam B back here, okay? And so here's how we can think of this. I'm going to redraw this. So we can maybe visualize it a little bit better. We're going to redraw it here. And instead of drawing the thickness, just for clarity, I'm going to leave off the slab thickness, okay? And then, we've got this beam under here, all right? And then we've got this other beam back here, okay? So what's going to happen is that 100 PSF load, half of it is going to be transmitted to this beam A, and the other half is going to be transmitted to this beam B, all right? And how is that going to be transmitted? Well, again, we think of the tributary width of each of these beams, okay? How much width in feet is going to transmit a portion of that load Q? Well, if we say half and half, that means that 15 feet is going to be split into 7.5 feet and 7.5 feet. So one way we can think about this is the loading on half of this slab goes to beam A and the other half goes to beam B. So if I were to try to draw this and kind of visualize it, that means that this portion right here, this is going to be loading, or let me rephrase that. I'm going to say portion of Q to be supported by beam A. And of course, we said this is beam A right here, all right? And then what about the other half of that? Well, I'm going to say this half is going to be portion of Q to be supported by beam B. Okay. Now, how is that going to get transmitted? Well, it's going to get transmitted as a uniform load on both beams A and beam B. Okay. So if I were to again sketch that out, I'm going to say 2D view of beams A and B. And so what would that 2D view look like? Well, if this is the line drawing of the beam, how long are these beams? Well, they're 20 feet. Remember, beams A and B are both 20 feet. That's this dimension right here. Okay. So what's being transmitted is a portion of that Q, which is going to end up looking like a uniform load spread out over that 20 feet. Now, what's the magnitude of that uniform load? Well, we're going to call it W, and it's going to be equal to Q times that width over 2. So that's 100 PSF times 15 feet over 2. Because again, the loading on this half gets absorbed or transmitted to this particular beam, and the other half goes to the back beam, or the other beam, beam B. Okay, I'll go ahead and label this one as well, beam B. So what's 100 times 7.5 feet? Well, that's just 750. So that loading on that beam is going to be 750 what? PLF, okay? PLF, pounds per linear foot. Where is the per linear foot? Well, it's along this 20-foot length, okay? It's along this 20-foot length. All right. Now, that's the conclusion of this problem. Again, this is more of a visualization problem, very little calculations. But again, we want to visualize and understand how these loads are transmitted from a surface like a slab onto supporting structural elements. And again, this was a one-way system because why? Because it's only supported along two opposite edges, okay? It's not supported on all four edges, okay? Now, could you check the ratio of the long dimension to the short dimension? Could you say LL over LS? Well, I mean, you could, but that's irrelevant here when there's no supports on these two opposite edges, okay? So that concludes this example. If you found this helpful, please hit like and subscribe and be on the lookout for other content like this. Thanks for watching.